Hi, my name is George Fan. I'm the CEO of Aerodynamic Solutions, and welcome to the video tutorial on the ADS Workbench. In this video clip here, we'll give you a quick introduction to the ADS Workbench, its capabilities, and how it can help you streamline the process of configuring your ADS simulation runs. Perhaps the best way to convey the value of the Workbench is to provide some context about how simulations are run in ADS. It really is a three-step process. First is you'll need to configure a set of 3 setup files required by Code Wand and Code Leo to execute. Once you've done that, you'll invoke Wand in order to generate the mesh, and then invoke Leo in order to initiate the solver. Now, power users can quite simply, without the use of the Workbench, go ahead and directly manipulate each of these setup files. But we think you can really save a lot of time and candidly heartache by relying on the Workbench to help manage this process for you. The ADS Workbench really has been designed to help simplify the process of configuring and executing your simulations. We support 4 types of simulations, ranging from very simple 2D cascade analyses to multi-row, multi-stage, 3D time-accurate analysis. And so whether it be the simple or the complex, you can rely on the Workbench to do 2 things. One is it will build all of the setup files necessary to run the simulation. The wizards will inherently help to validate the entries that you're putting in and to avoid any sort of conflicting entries that you might accidentally put in yourself if you're directly manipulating the setup files. The second thing it will do is it will generate for you the files for local execution. By local execution, we mean execution on your desktop, whether it be single core, dual core, quad core machine. We have the ability within these scripts to execute using MPI-CH2. Now, for those of you that are executing your CFD analysis against the large clusters of computers, then you can refer to the ADS User's Manual for information about how to set up your own custom scripts for invoking Leo. The Workbench is organized into 4 primary views. The first view is the Project Explorer view. The Project Explorer view gives a user visibility to all the projects and simulations in their workspace. A workspace can consist of 1 or more projects. Here we've defined 2, and each project can consist of 1 or more simulations. So in this example here, 3-row design might be for a turbine compressor. We have associated 5 simulations with this project. The first 3 here might be the 3D single row steady analyses that we performed on each of the rows. Another one might be for the multi-row steady analysis that we performed. And another one might be associated with the multi-row time-accurate analysis that we performed. All right, so the Project Explorer gives users visibility to the projects and the simulations in their workspace. The next view is the Wizard view. The Wizard view is presented when a user defines a new simulation using one of the 4 pre-built wizards that comes with the Workbench. We've built wizards that will allow you to define 2D cascade analysis very easily, another for 3D single-row steady analysis, another for multi-row steady analysis, and finally for 3D time-accurate analysis. So let's just choose a 2D cascade analysis just for simplicity and give you an example of what this experience is like. So the first set of questions really just has to do with administrative things. What project do you want to associate this simulation with? We'll say 2D airfoil design, and a name for the test case, we'll call it test case. The wizard will start to present all of the detailed parameter data that it's looking for. You can see here that it's looking for airfoil geometry definition. Part of that is specifying a raw geometry file name. And what that contains is the set of data points that describe the airfoil. It asks for the number of points. It asks for the input format and additional information, as you can see here. We're not going to get into the details of what these parameters are. There will be additional tutorials that step you through the process of configuring each of the 4 types of simulation runs. Anyway, as you go through the process here of using the wizards, you're only presented with the information that is relevant for that type of simulation, and the system is performing validation at every step of the way to make sure that the answers you're providing are in fact legitimate or coming from a restricted set of choices that are available Okay, so when you're finished, you'll click on Finish, and what will happen now is the Workbench will begin to build the simulation run from the information you've provided it. This brings us to the third view in the Workbench, which is the console view. The console view gives you a window to the process that the Workbench is embarked on to generate the setup files for this case. All right, you can see here that for test case.xml, that it has attempted to build an arrow geometry file. One of the steps in that process is to import geometry data from the file we pointed it at, and to perform data validation on that file to make sure the right number of points and entries per row are there. Once it's done that, it's actually gone off and generated the WAN setup file and Leo setup file successfully. So build is successful here. That's great. So if we take a look at the test case folder that we've created, we now have a set of files that have been generated by the Workbench as a result of the wizard and the build process. We have the case definition file, which is the XML file. We have the 3 setup files required by WAND and Leo in order to execute, and we have the 2 executables here that are built to invoke WAND and Leo to carry out the simulation run. This brings us to the fourth and final view, the editor view. The editor view allows us to modify and execute simulations that we successfully defined using the integrated wizards and built the setup files for using the Workbench. Now let's just say, for example's sake, we wanted to make a couple changes to the case we've just built. Let's just change the inlet mock-in number to 0.15, and let's just reduce the number of iterations for the solver from 4,000 to something like 500, just for demonstration purposes. We'll click on Finish. The case rebuilds, the files are updated, and now we have the ability to execute the case using the 2 commands down here in the execute case screen. To generate the mesh, we click on the link here. The mesh gets generated. The way that we can verify that the mesh has been generated is to update this test case folder and to look for the existence of the restart file called test case. So if we refresh the workspace, lo and behold, we in fact do have the restart file. It's called test case, and now we can use this as input along with testcase.leo to execute Leo. To do so, we just click on Run Leo, and the Workbench automatically invokes Leo for execution on your desktop machine, and in a minute or two we should see successful execution. When the command prompt screen disappears, then we know the execution is complete, and once again, to verify the fact that the execution has completed successfully, we can refresh the workspace. We see the existence of a whole new set of output files. The one of interest to us is the convergence history, and we can take a look here to verify that in fact 500 iterations have been completed. So there you have it, an introduction to the ADS Workbench. In sum, the Workbench streamlines the process of defining and executing your simulation runs. By using the Workbench, you'll be able to take advantage of a number of time-saving and heartache-reducing features. For example, 4 pre-built wizards to speed along the configuration process, input validation to trap and reduce errors, automated build of setup files and local execution scripts, and finally, simplified file organization and management provided by the Project Explorer. We'd encourage both novices and power users to use the wizard as an educational tool. The product's currently available for Windows and Linux, and as a foundational product for ADS, you can expect to see all sorts of enhancements for this as we enable more capabilities for Code Leo and Code WAND. With that, I'd like to thank you for your time, and if you have any questions, I encourage you to post your thoughts on the website or to send us an email at info@adscfd. Thank you.